and in this person. All right, so yeah, this machine right here, right? If you remember correctly, is called a meter. So this is an analog ammeter, analog, and this is a digital ammeter. All right. So these essentially measure electric current. These two measure electric current, but this gives you this you have to read the scale, and this gives you the reading already. So this is a digital ammeter. All right. So electric current is measured in amps, right? Using an ammeter connected in series in the circuit. And we'll talk about series. No. All right, but when you think about electric circuits, you should essentially think about a river, right? Right. The flow of charges, this would be called a current. All right. The flow of charges or the flow of the river we would call it a current. All right. So essentially, the ammeter would measure how fast this current is moving. All right. Are you hearing me? Just a check if you're hearing me.
Yes, sir.
All
Yes,
right.
sir.
So let's move on. Right. So we said that these the small, remember in the exercise we saw some small let me see, let me try properly. We saw some small blue items in here,
Bubbles. I can call them electric.
right? So these are called electrons. So these small things in here, these would be called electrons in your wire. All right. So the current, the actual substance that is flowing through the wires of the circuit are called electrons. So the actual substances that are flowing, the blue stuff, those are called electrons. All right. So is this clear? Right? The actual substances, that's what I want to get here. The actual substances that are flowing are called electrons in the circuit. Is that clear?
Yes, sir.
All right.
Yes, sir.
Now we now move on to the structure of our circuit, right? And we see a battery here. This is our power supply. Or battery, right? This provides power to the circuit. So the power would move, for example, in this direction, right? To the light switch, and you can use this switch here to control the the light or the basically the electrons flowing in the circuit. You can use the switch here to control. So you can turn it off, and that shuts off all the power in the circuit, or you can turn it on. So the cell or the battery, this is our symbol for the battery. This is our lamp. We have our switch here, and we have our wires. So these are the various symbols for the different components. So we have our cell here, or our battery, right? And then we connect to our wires. We have a lamp, say here. This should be our lamp. And we bring over this, then it would look. Then we bring our switch here, which is the control of the system or the circuit, and we close our circuit. Right? We have to ensure that the circuit is closed so that current has a full path to
Yes,
flow.
sir.
All right. So I think I have something here that displays that much better than I drew it. Yes, I do have something here. So you see, you have the wires, your dry cell, or this could also be called um, power supply or battery or dry cell. So these are some names for our battery, all right? And the symbol for lamp and switch. So is this clear?
Yes, sir. Sir, a button or button?
Battery.
Oh,
All
button.
right. Sorry for my handwriting. Let me see if I can.
So, sir, can the power cell like run out or electric?
Go again.
Can the power cell run out or anything? Like dry, run
Oh yes, that would mean that the battery would be dead, or it has no more power.
So we'll
All
have
right.
to replace it, sir.
Yeah, so you'd have to basically replace the battery. All right. All right. So now we look on series and parallel circuits. Let me take this off. This is the last thing for today. Let me just remove this. All right. All right. So a series circuit. So basically, series circuits are all in one row. One row, right? So you have, let's draw back our supply here, and we have our wires and one lamp, two lamp, and three lamps here. Now, if
Wire.
we, and we put our wires here. Now, if we connect our wires, close the circuit, all of these lamps would come on, right?
Will flash or get brightened.
Exactly. Now, electricity has one path to flow. So electricity will flow from the source power supply here to go around and then return back to the power supply. It has one complete path. So it's a circle, a cycle, right? So if one light, say we disconnect one light, what will happen to the entire bulb, the rest of the bulbs? What will happen?
They will come out, sir. They wouldn't give any light.
Right? So they would not give any light, which means that no electricity would be reaching these bulbs. As you can see up here, if we put all the three bulbs here, we see that there is light. But when we take out one of the bulbs, right, there's no path for electricity to flow. All right, there's only one path there. So therefore, all the lights will turn on. Now, on the other hand, for a parallel circuit, took something like this, and you have a bulb here or a lamp here. You have another lamp here and one more lamp here. Essentially, what if we turn off one of these, or what if we disconnect one of these lamps? What will happen to the rest of them? Will they turn off as well?
No, sir.
Right. So they will not turn off. As we can see here, if we disconnect one of the bulbs, the others are not affected because we have more than one path for electricity to flow. All right. So parallel circuits, there are many paths for electricity, right? So if one light goes out, the others will stay on. The others will not go as well. So how many paths of electricity? Let me just add this back. Now tell me, how many paths of electricity are there now currently in this circuit? This one right here.
Sir, 3.
Right, so there are three parts of electricity. You have one here, you have one here in the second row, and you have from the power supply to the third one. So for the parallel circuit, there are 3 paths for electricity to flow. But for a series circuit, how many paths for electricity flow is there?
1.
Just 1. All right. So is that clear for everybody? That
Yes,
clear?
sir.
Anyone don't understand series and parallel? All right. I'll take that as a yes. Any questions?
No, sir.
All right. There are no
No, sir.
questions. All right. Ms. Brown, you have any questions? All right. So that would be it for today. Tomorrow we'll do an activity where I will let in 5 persons at a time to do to see if you really understand. All right, just to do a little practice session and construct a circuit online.
Sir.
All right,
Sir, these notes will be in Google Classroom, right?
right. So I'll upload these as soon as the class is finished. All right.
Okay. Yes, sir.
So if there are no more questions, we'll have the activity tomorrow. So I will let in 5 persons at a time tomorrow, and you will construct a circuit. All right. So the first 5 persons that come will construct a circuit, and then the second 5 persons that come will construct another circuit, and we will continue that for the rest of the time. All right. So the earliest you come, the quicker you can be finished with that class. All right.
Sir, everything like what we do already we go get an exam, right?
Yeah. So everything that we have,
We're gonna do this.
right. So we'll also be doing electricity. So next week we'll do more revision, all right, on these topics. Mostly revision we'll be doing.
Okay, sir.
Okay, all the best, everyone. All the best. Enjoy the rest of your day.
Thank you, sir.